intro. Should do that before I stream. Right, I wasn't expecting to stream this weekend, but I appear to have found some time. The previous sort of review, I think, sounded a little bit depressed. I wasn't depressed. I was just tired. Not tired of doing this. Tired from being worn out and tired. So anyway, end of March, we decided to rethink, kind of dropping the interpreter stroke language for a while. I may pick it up again. I'm unsure. And the other thing was we were working on a little streaming of a little game we were calling Squares. It's that I was making. I'm keen to carry on that. I'm quite enjoying it. So today we're going to do that, but there's changes again because when you start one change, I rethink everything. And after 2 episodes into that game, we are going to move over to Rust. We don't have that much invested in the SDL thing. We've made some pretty good progress, but nothing we can't redo in a few episodes. I'm not sure the motivation for using Rust. Rather, funny enough, I started the interpreter using Rust at the beginning of February. Got 2 episodes in and converted to C++. 2 episodes into the game, and I'm moving over to Rust. I like Rust. It compiles a bit slow. That annoys me, but you can use the checker and you can get around that. So our game is plan is to use Rust. We're going to, for those of you that don't know Rust, which I find highly improbable if you're watching this, let's drag that one onto the screen. Rust. Why Rust? The 2018 edition is here. Blazing fast, memory efficient, no garbage collection, performance critical services, blah blah blah, reliable, super good type system. You'll be productive. It does have great documentation, it does have good error messages, it does have good tooling. It could be better in some instances. Certainly the IDE supports are still improving. It does have with auto completion, yes, type expression, auto formatters, blah blah blah. So everything you'd expect from a language. It's nice. It's a great competitor to C++. C++ is, I'm not sure whether borrowing ideas, maybe borrowing ideas, but C++ was heading in this direction anyway, and Rust is just a new language that's got there before, new being it's only a decade old. I was talking about Zig previous episode, and I did have a little play of it, but I like it. It's a great alternative. If it was at version 1, we would probably be starting on Zig here. Kind of want some better IDE integration, kind of want better documentation, kind of want it to be version 1. Excuse me, when that appears, ooh, I would be very happy. Zig had some nice takes on things, and importantly they were very keen on simplification and minimising the cognitive load the language has on you, which means you get more time to think about your problems. Rust, I would say, doesn't do that. I have to think about Rust quite a lot. That's not a bad thing. I'm sure if I code more in it, it will fall away into its background, a bit like C++ does. But they are 2 different languages trying to achieve similar ideas. If Zig was developed, if Zig was further down the line, like I say, I'd probably be using that. They're both solving a lot of the problems around programming. So you've got Rust has got a nice package manager, so it's easy to download stuff. Blah blah blah. Build tools are easy. It's relatively easy to build for WebAssembly. It's relatively easy to do. I think it's relatively easy to do Android stuff. I've not checked, but yeah, they have got a big focus on solving that as a unified group, where C++ is a bit dispersed. It doesn't. There are package managers, but they're third-party things, and perhaps Clang is, and the tooling around Clang is the best we've got in the C++ world, with something that's running a compiler and an awful lot of extra tooling. That pretty much sums it up. Apparently, you can do good predictable networking. Lots of companies are using it. It's growing. I mean, I wouldn't still fairly young in its, sorry, I've got an itchy eye, fairly young in its, still fairly early for Rust. I mean, but it's certainly past the whole, you know, will it succeed or not? It's got enough contributors, it's got a huge community, and people are really writing a lot in it, and they're really good at documenting stuff, which is useful when you're learning, certainly. So with that in mind, if you want to learn more, go there. It's quite easy to install and play with. There is a book online, free, blah blah blah. Read the book. There's some other things, Rust by example. An awesome book that does a good introduction. I've read it twice actually, but not in the past few months. So it does mean, I think I read it around Christmas time, it does mean that I am going to be struggling with Rust, and I will probably have this documentation up, or I'll be googling a little bit. Hopefully that will smooth off as we go forward. And, I will forget all the basic stuff, so excuse me. I will stop and look up how to create a structure, or I will keep using C++ idioms and getting where I declare my types wrong. So expect slowness, expect stupid remarks as I go, and expect me to get irritated with build times at some point, because I will. But I'm going Rust on this. I'm trying to only use Rust at home for a month or two to submerge myself into it, but we shall see. Okay, the next thing is, I don't want to go from program the game from scratch. Sorry. Something's in my eye. Great fun. So there's two. No, we don't want you. No, we do sort of want you. There's this library. Let's see if I can. Yep. For 2D games, and there's this library. So let's maybe put like that. They're both serving as very similar, provide very similar features. We will, before we even go anywhere, we will be using Quicksilver. Great Games Made Easy, based on the Love game framework, which I'm not that familiar with, but the API is pretty simple. Electrical steam frame still. Only 3 apps, but hey, got to fuck around them twice. All we want to be able to do is draw some squares in this game, write some text out. That pretty much covers it. The other thing we want to be able to do is compile to WebAssembly, so we can actually put the game on the website. Demo, not really going to be much of a game, I'm afraid. We're going to have some bugs in there if we have to. By bugs I mean gameplay bugs, or things not quite working right because we're using fairly young libraries still. Neither of these are at 1.0 releases, which is my major complaint about Rust actually, that it's young enough that most applications are not above 1.0. So you're kind of expecting things to change, or they're going to die out, or they're going to restart. I mean, Great Games Made Easy, I know it's been up and down. I think the main dev on it was trying to take a step back and let others in, which I'm sure they are. I have not checked. Let's look at the comments. Oh yeah, plenty still going on. I think this person's the one who created it, but I'm not sure. Yeah, still plenty going on there. So anyway, either of these is a good choice. We're going with Quicksilver. I have played with that a little bit 6 months ago. Quicksilver is going to be cool. So, without further ado, I've created a very small, still using C-Line, that it has some support for debugging Rust. I'm not sure how much in terms of visualizers. But Visual Studio Code would also be a good one if you're looking for something that works well, but for now I'm going to stick with C-Line because I've got used to it. I might have a play at some point on some other editors, but they have an emphasis on trying to get the editors working well. I think it's C9 Visual Studio battling out at the moment. So this is, as you probably know, the description of the project. Called it Squares, from version 1.1, me, VGBind. We're using a 2018 edition of Rust, and we have to put a dependency in. Quick. Silver equals. There you go. C-line's awesome. It gave me the latest version number, so you just type your dependency in here, you do that, you give the version number, and it will figure out the best it can. It won't move up a version, but it might not give you 11, it might give you 12. Actually, it'll probably give me 11 because I specified it precisely. But there's a lot to it that I can't remember the details of. That is now going to, much in a way like we could download STL via CMake and build it, this is going to download Quicksilver and build it for us. The problem with downloading STL in CMake was I couldn't then also download easily. I'm sure it's doable because I'm not a CMake expert. When I come to download, say, STL font or something else that depend on STL, it wouldn't download it and pick it up. It was going to say where's the STL library, and I couldn't figure it out. Didn't try very hard, but thought of the point I don't want to try very hard. I just want to type Quicksilver equals this. I just want to type STL equals that. And, when we build that, well, it looks like it downloaded it all in the past. Well, it had downloaded it all in the past because it caches all the downloads. And I was running through a few examples earlier on today. What I will do to show you some fun stuff. Let's put it in Emacs. Go over to the side while we wait. Still compiling, still compiling. What should I mention or talk about? The interesting many. If you see my stats, that cool. We are still streaming okay. We are. All is going well. We've got medium health, which whatever that means. Home. Awesome. And it's saying I'm live now. Great. Oh, it finished. Took 1 minute. Obviously this is doing more than STL, but STL took about 11 seconds, didn't it, if I recall? Yeah, I'm doing a lot of comparative stuff because I know what I'm giving up by moving to Rust, and I don't like giving up some of the stuff we're giving up, but hopefully we'll gain it back in awesome. Should bring that onto screen. So what I've done is I've cut and pasted everything it compiled. I'm then going to delete those two off. Make it a little bit bigger. For some reason my highlighting in Emacs is not great for a region. So I sorted them all. And now if you look, for instance, here, you'll see, because of it's resolving dependencies and other dependencies and this, you see we've actually compiled in two different versions of a prox. So Silverlight, Quicksilver, I want to say Silverlight because it's got silver in it. It's nothing to do with this thing, it's totally C-sharpy thing. Quicksilver probably didn't use these, but its dependencies is, and you just see it cascading down. Now STL has some dependencies, obviously, for instance, but you can see there's an awful lot of dependencies here that it's compiling in. Number trace, we've got 2 versions of, and this isn't a complaint, I suppose, because you could have the same thing happening in any compiled language. You know, a certain library depends on something, it compiles that in, and off you go, and it's important to support that sort of thing. And so yes, uses Wininish. That's interesting. Did wonder what it used. Oh, we thought I'd show that. I don't spend my whole life yawning. It's because I'm talking loads and I'm not breathing properly, I guess. So my brain goes, you need to yawn to get some oxygen. And once you start yawning, you can't stop. Right. So next up is we built it. So just a crate. Quicksilver. Ooh, how do I import? I've got the tutorial server. Let's show that because why not? This is the documentation they have online for Quicksilver, and we're going to, at least initially, I've worked through the tutorials but I haven't memorised them, so we're going to go into the tutorials and we're going to use that as a way to get cells working and going. Oh, right. So, we've said it's an external crate. And of course, use was the word I was looking for. Quicksilver. Okay. What are we going to use out of here? It has its own result object, which is cool. I have no opinions. It has its own geometry vector, which is obviously a resizable container of points. And nice circle. Oh, I didn't do my usual. Welcome to a live stream of us writing should be a very small game in Rust, not C++. Struct screen semicolons. I'd like to see less semicolons because mind you, then I miss them. So. New is the default way to construct structures in Rust. I'm probably going to talk, but if you're thinking of learning Rust, I am not the person to learn it off of. That is for sure. At least not at the moment. So what don't you like there? No, good. I think you read, in this case, run with type or has type. I know you can spot that. I shall growth a little bit, but C-line is filling in the parameters here to let me know what each one is, which is great. Vector. 400 by 400, that's the screen size. And then the final thing is default, so all the other options on the screen is we just take the default settings, so it's going to be V-synced, it's going to be non-resizable, it's going to be not full screen. We can alter that later on. So what have we done? This is literally following the examples, so please look there. We said we've got an external crate called Quicksilver, so we're like, yep, the compiler knows something called Quicksilver. We're using some things out of Quicksilver, so we're using the result object for returning optional things. We're using the geometry vector object, and we've got some nice samples, state and run. We're using run down here, and state is the thing that run needs to be able to call into things, so it is the outer loop. Quicksilver takes over the outer loop, so it's not a library, it's a framework. I generally prefer libraries for controlling the outer loop, but not strongly, and you kind of need to do you end up having to write something anyway if you compile to WebAssembly, because it's event-driven thing, so it calls back to you, so you need to provide a callback to it. Maybe JavaScript, I'm not really sure where it goes, saying call this function every 60 seconds, so every 60th of a second, or as fast as you can. So you end up having to do some stuff there. So I'm happy. You can't have a single outer loop if you combine it WebAssembly and the desktop. Desktop runs you're in control. You've got a loop, whereas WebAssembly it calls you because you're in a browser. The browser calls you every 60th of a second. So that's slightly why you end up having to write your own framework or using someone else's framework. You need some generic code. Probably a good example of that would be looking at in the Raylib library. It's not much code. They just have a little if define in the C code to see what to do. Raylib doesn't take over, but it gives an example of how you'd write the outer part. God, that's a lot more complicated than what it is. It's really simple. Right, let's run this. Let's see what happens. First thing we'll notice is build times are awesome. 1, 2, 3. Okay, segment gives us a warning. We're still able to print. It took 3.9 seconds to build. Now, hopefully that will scale nicely across my CPU cores, of which we've got 6 and 12 logical. AMD 1600 or 1600X, so mid-range AMD from a year or two ago. Yeah, two years ago. I don't know, something like that. We're not a super spec machine. I think it's only got 8 gigabytes because memory was pretty steep back then. Now what are we doing? Right, first thing. Well, cool. Look, we got something. It's a black screen. Who would have thought? Black screen. Right, well, next thing we need to do is draw something. So, guess what we've got to do? We've got to add some extra things. Well, we're going to want to draw a geometry, so rectangle, vector again. So add that, and if we're going to draw something, we're going to need to know about the window. So we put that there, and we're going to need to know something about graphics. And what do we know? We need to know about background and colour. So now, not just new, we need a new function called draw. And that's going to take a mutable reference to yourself and a window, which is going to be a mutable reference to a window. That's going to return result. Oops, what are you doing that for? Yes, you do want that. And if you can leave off the result and let it infer it, or does it just infer a unit? Window dot clear. COLOR. Got some problems going on there. We just type so quickly, don't it? And I'll put an extra reference on self because I'm thinking reference C++, that's where you'd put it. And we've got white there. This returns a result, so we're going to put a question mark, we'll say just return, propagate out the result. And window.draw, we want to draw a rectangle, so we presenting a reference to a rectangle, new, let's just follow the tutorial here, 50-50, comma, 100, comma, 200, 1, comma, no, one there. I'll explain this in a second. And okay, boom boom. So now I don't think we need to change anything else. So all we're doing is now because draw exists, I guess the default implementation is state. I'm not sure. Let's have a look. It's interesting. Yes, look, there's a default implementation, it just clears it to black. That's what we were relying on before, now we're overloading it. I wonder why it's a static there. No idea. So traits are a way of providing interfaces, or saying an object has a certain interface. This is a really concise way of saying we've got a structure, but we haven't got anything in it yet, so we don't need to cut braces, we don't need to do anything, it's just, hey, there's a structure, you're empty. I wonder if they've got a minimal size, like, it's got the same rules, so I must be able to take an address of it, so the size can't be 0, it must be something else. Sure I can look that up, but I'm not going to at the moment. These are all wonders. Let's see if it works. So compiling, woohoo, 3.9 seconds. Which is not great. Got a red square up on a white background, and I keep pressing escape. I'm about to put in some stuff. So background is, I find that slightly weird object. So what are we saying here? We're drawing something, we're drawing a rectangle, which is pretty obvious. And the background is basically the fill colour. Background can be something else, it could be a texture, an image, maybe something else, I'm sure. But background is weird, it feels like, well, you're not the background, you're the fill colour, or the fill, just F-I-L-L would be a good object rather than background. Background sort of implies the thing behind your object, even though you, yeah. Anyway, not a problem. So, we're here. Right, let's move on to the next tutorial, because we're getting what we want out of this. Next is input, and you're not going to believe this, but we have to add a few more things. Input, key. I don't have much else. Okay. Well, now they've been moving the square around, but we're not going to do that. We're going to do, so we have to add another, implement another method on the state trait, which is called fn update, and it's just this again. There we go. Does that we want to sort out its colouring? Doesn't seem to want to. That's better. Okay, so if window.keyboard key no, spell key wrong, Paul. That's weird. Escape. What is down? How do I exit a program, I wonder, in Rust? What's the... No, just one of those things. Exit a program in Rust. How do I exit program only from outside? Stood process. Yes, looks like we need to use stood process exit. Stood process exit. That. Well, let's see if you can do some auto. So again because of that. Okay. Should not go to here. One of my favourite things is this. Due to terminates the current program. This program will never return and let's just do that. Okay, I'm guessing zero is the I think okay exit code. We don't do any cleanup, which is probably quite bad. Cool. So it's complaining here that we don't have an asset directory. I'm not too worried about that. But let's add one anyway. It's where we will store data, and we have to call it res, like you do in Android, unless that's changed sometime in the past 5 years. So we've got an update, we've got that. I wonder how we read the mouse. It's not mentioned here, is it? Mouse button. Key. Mouse cursor. Now I wonder what we can do if I'm not pause or if when I press the mouse button, I think we've got something about mouse buttons here, haven't we? Mouse, oh look, you can do that. Mouse button. Left dot is down. Print line. Oh, let's make it debug. It's bound to be. Need that. Take that. Oh, I do think you should have already set a function. That's fine. So it's constantly reading it, so it will be good for that. Here we go. So we have that, but let's add in, because I often do, one 1, 2, 3, 4, 5. Great. Yeah. How are we doing? 10 past 10. How long have we been streaming for? Struggling to find even my. It has been streaming for. Oh, only 35 minutes. I must have started later than what I thought. Hello, welcome to episode 3. Episode 3. Yeah, I'm not sure that's going to update, but hey, nothing much going on here. Okay, so I keep saying okay, but I've not been saying so much, I don't think. Here we go. All is good. Right, so we know how to draw a rectangle. We know how to clear the screen. That, and we know how to read mouse coordinates. That is all we need. So let's make a player. What we want to do is I want to know if we can get a mouse delta. Which will be useful. So pulling up the docs again. What can we find in our docs? Examples of deploying graphics input. Mouse, simple mouse. Delta from last frame I was hoping for. Nope. There is no delta. Shame. Okay, we shall manually roll that then. No. I missed it, but no point. Look at that, I don't know what I'm doing. Mouse pulse. Vector. Now we need to, in our new, we can no longer do that, so we can do pref mouse pulse. Vector. What do we do? Will we get away with that? Doesn't look like it. I don't think the vectors are initialized. No. But there is one there. Oh, pardon me. So sometimes, and I say this in a nice way, it reminds me a bit of Dart, the programming language. What do you mean you don't like that? It's all caps, isn't it? Now each time we come into here, we want I mean, this stuff is really handy. And again, must be a function call, because that's the way Rust works. Let delta equal current minus have they overloaded? Yep. Delta and I'm guessing not then. No, that's what current call. Floats. Now, one thing I want to do is okay. Actually, we can have a normalized direction. That would be better than normalize it. That way, sure, if you've got some crazy stuff going on, you're not shooting away. And then I wonder if we can scale. Normalize current cost product distance dot into len 2. What the hell does that mean? Reciprocal times. Oh, I guess that's a good thing. XY component add divide equals format mul. Why no scale? Center. Oh. I guess we go with times. Nope. Syntax, enough. Glad that is. Nance. Normalizing 0, 0 is going to give a nan because it's got 0 magnitude, isn't it? I think that's squared. Oh God, okay. In the UK we say normalise with an S. Not that. Come on, you could have inferred that. Okay. Remove these parentheses. Yeah, I'm with you on that. Cool. Okay, so what I'm doing is I'm trying to work out which way to move our player square, which is pretty good. We're going to do that. So now we're going to do self.player.pos equals plus equals this pretty much. Entity, game object. We're not doing a data oriented approach to this. Player. Put a semicolon there, yeah. Now I need to do something like hash ring. No. A couple of the syntax lists in Rust. Derive. Is hash square brackets. Debug. Why are you not like that? Of course. Again, I've got it all the way around. That is going to be a very common theme. So when we were coding the interpreter, I kept messing up my case statements, forgetting to put breaks on them, which is crazy talk. You are entity, maybe. Semicolons are so ingrained, I'm going to take a long time to get rid of those. The only way of constructing is you don't malloc, you call the editing new object and creates a new object, returns for you. If you wanted to have a dynamically allocated one, you would either do it in here and return a boxed entity, which should give you basically a unique pointer, or you could do a atomic ref counted object. You could do a ref counted object, which should be an arc, and then there's an atomic one, which I think is an RC. No, RC is that. RC is the non-thread safe one. The arc one is atomic ref counted, which is thread safe. I'm not that familiar with Rust threads and what goes on, but it's meant to make it easy. He's not happy. Oh, it's called static, not res. It's not the same, I just trimmed that. Let's change, oops, let's change you. Rename only thing that lives in there is when we add a font, which you can load TTF fonts. First instant, which is what you'd expect. Now, you need velocity. And constantly go towards that. And we do that all the time. And we're just going to actually record that out for a minute. And then what's these 5 pixels a second? It's going to be awesome. So self dot player dot pause equals pause equals times 1/60. I reckon I'm going to crash in a minute. Not the program. That's call it a night. Self dot. Cool. That just kept getting bigger. That is weird. Ah, I call that a night. Working on this. Right, we've got some way going. I'm not in the mood for debugging. My aim was put something simple in there. Might be even that. Will be a good excuse to try to debug out though, so I'm not going to look at the code too hardly. I want to throw the debugger on it to see how the Rust debugger debugging experience is. Also, yeah, doesn't matter. So my aim tonight was just to get Quicksilver set up and get something on the screen, which we did with great ease. So now what we're trying to do is we're just trying to get a player to head towards the cursor, and then we're going to draw a rect on it. That's going to be our little thing that floats around the screen and tries to dodge other squares. So original. Anyway, with that, I think I'm going to call an end to the stream. It's not screen, and we shall return maybe tomorrow, maybe Monday, maybe Tuesday. No, not Tuesday. Maybe Tuesday. Most definitely not any other time in that week, I don't think. Right. Okay then. Thank you very much, and I shall see you again.